right, so we already did lesson 12.0. So this whole packet is about data analysis. So it's got a lot to it. Definitely need a calculator. So if you need to stop this video and grab a calculator, I highly recommend it. I'm going to try to mess with the color on here because I've got sunshine coming in. This looks pretty good, not too bad. So this is specifically called statistical analysis. So what you are doing is you are trying to find that variance. So this shows us the variance. So our variance is showing us how much something varies. And then how far are we from the mean? So how far from the mean? How far from the mean? I do want to go back to the lesson prior. There was 2 mistakes here, or 3 mistakes. So it should have said find the median. Here, find the median, find the median. So all those words should have been find the median. Sorry about that. So the medians. All right, so this is just 1 page of notes. And here are the instructions. I'm going to read them and then we're going to do them. So first of all, we find the mean. We know how to do that because we add, then divide. So add, then divide. Do not punch this all in the calculator at once. It will not like it. Next, we're going to find that variance. So variance is how much something varies. So if it's a high variance, then it's wide, just kind of like that box and whisker. I don't know if you can see this on here. So for example here, this has a wide variance compared to what's up here, this box. This is a small variance. So that's kind of what we're looking for. And they use this, if you take statistics, which you will probably have to do at some point, you'll be doing this. So let's go ahead and find the mean. So where's our data? So here's our data right here. So let's find the mean. So I'm going to add all of those values up, hit equals. So I'm going to say 9 plus 10 plus 11 plus 6 plus 9 plus 11 plus 9 plus 8, almost there, plus 11 plus 5. So I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 pieces of data. Always make sure you hit equals on that before we divide by 10. Divide by 10. Okay, so let's add those up. You do the same. I got 89. So I'm going to say 89 divided by 10 is 8.9. So there's my mean. If you had an outlier, you can leave it off. You can leave it off if you have an outlier because it's something that does not belong and it would not make a good mean. So if you're doing mean in this particular situation, it says you have to use mean. So if you have an outlier, you do not include it. Okay, so now we are going to find the absolute difference of each number from this mean. So our first number is 9. I'm going to subtract our 8.9. Our next number is 10. I'm going to subtract that 8.9. My next number is 11. I'm going to subtract that 8.9. My next number is 6. I'm going to subtract 8.9. 9, subtract 8.9. 11, subtract 8.9. 9, subtract 8.9. Yes, this is a pain in the drain. 8, subtract 8.9. 11, subtract 8.9. 5, subtract 8.9. Oh, we finally got that. How many numbers were in this data set? We know is 10. Okay, so now in your calculators, you need to solve that. So what is 9 minus 8.9? I get 0.1. So 0.1 squared plus, I think there's another couple of those. There's another one. 0.1 squared. 0.1 squared. Okay. How about 10? Let's go 10 minus 8.9 is 1.1. 1 squared. Is there any more 10s? Nope. 11 minus 8.9. 2.1 squared. 2.1 squared. 2.1 squared. Yes, this takes lots of time. What's our next one? 6. 6 minus 8.9. You get a negative value. So up here when it says, making sure all numbers are positive. So we're just going to take the absolute value of that, which would make it 2.9, distance from 0. So you're going to make it positive. 2.9. It's a 6. Any more 6s? No. Almost done. 8 minus 8.9. So it's just going to be a 0.9 squared. This one we did, and then again, 5 minus 8.9 is going to give us a negative, but we take the absolute value of that, so it is 3.9 squared. So what you're doing is you're finding just distances from the 8.9, and that's why they're all positive. It's the absolute value difference. Okay, this is what's going to be fun, because we need to take all of this in our calculator and divide it by that 10. So here we go. Parentheses, 0.1, parentheses, and I'm going to use the squared button. There's a squared button. Some people use the caret key, but I'm going to use the squared button. Plus, I'm going to cover them up as I go so I know what I've done. Parentheses, 1.1 squared plus parentheses, 2.1 parentheses squared plus parentheses, 2.9 squared plus 0.1, I forgot my parentheses, 0.1 parentheses squared plus 2.1 squared plus, I'm running out of room here, parentheses, 0.1 parentheses squared plus 0.9 squared plus, almost there, 2, forgot the parentheses, 2.1 squared, last one, parentheses, 3.9 parentheses squared equals 38.9. So my variance, hold on, so that equals 38.9, and we're going to divide this by 10. Divide by 10, and I get 3.89. Okay, so this is my variance. That's how wide the distance in that box is. You can't see that. Okay, so that was a lot of work. So now we need to find the standard deviation. That part is super easy. So to find the standard deviation, take the square root of the variance. So I'm going to take the square root of 3.89. Calculator. I have to hit that second key. Square root. Make sure you hit the square root. It's the opposite of the squared. 3.89. And we'll round it to the nearest hundredth, so 1.97. And since we rounded, we probably should put the ziggy-zaggy lines like that. And that's how you find a standard deviation. Holy cow. Yes, that's why this is just one page and it takes a lot. So that's how you do it. Trying to think of how we can interpret it. Again, it's talking about that variance. How far away are you from the mean? So if it's a small amount, that means the data doesn't vary very much. If it's large on a number line, then something varies. And again, I talk about the temperatures in Missouri. They vary a lot. So they're going to have a wider or a bigger variance or standard deviation. If you're looking at the temperatures in Florida, they all are about the same, the average temperatures. So your standard deviation will be a smaller amount. And these values actually stand for, sometimes you can see if you have an outlier, different things, but all you need to do is learn how to find the standard deviation and kind of understand what it means. So there you go.